Okay, so chapter 8, we're still continuing to talk about triangles. We definitely talk about triangles a lot in geometry. Some of this stuff should be familiar, so you've heard of the Pythagorean theorem. So if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if I have A, B, and C, so A squared plus B squared equals C squared, okay? A Pythagorean triple is a set of non-zero whole numbers A, B, and C that satisfy A squared plus B squared equals C squared. So as an example, 3, 4, 5. 3 squared plus 4 squared. So 3 squared is 9, 4 squared is 16, and that equals 25, which is 5 squared. So it's a set of non-zero whole numbers, so these are whole numbers that work in that equation. 5, 12, and 13 is another one. 7, 24, 25 is another one, and there's lots more. All right, the legs of a right triangle have lengths 10 and 24. Find the length of the hypotenuse. So 10 squared plus 24 squared equals C squared. 676 is C squared. Take the square root. So C is equal to 26. All right, the hypotenuse of a right triangle has a length of 12, and one leg is length 6. Find the other leg length. So 6 squared plus B squared is equal to 12 squared. So B squared ends up equal to 108. All right, if I want to leave this in radical form, so I'd take my 108 and figure out what perfect square goes into 108. That didn't work. 36. So 108 is 36 times 3. So B squared is 36 times 3. So if I take the square root of both sides, square root of 36 is 6. Square root of 3 stays under the radical. All right, the converse. So it says if the sum of the squares of the lengths of two sides of a triangle is equal to the length of the square of the length of the third side, well, this needs to be the longest side, then the triangle is a right triangle. So here I have a triangle, A, B, C. So if A squared plus B squared is equal to C squared, then triangle, whatever that triangle is, the triangle is a right triangle with C as the hypotenuse. Okay? So the next example says, identifying a right triangle. So a triangle has side lengths 16, 48, and 50. Is it a right triangle? So this is the longest, so that has to be the C side. So I'm going to check 16 squared plus 48 squared. And I want to know, is it equal to 50 squared? So 16 squared plus 48 squared, 2,560. 50 squared, 2,500. Not equal, so no, not a right triangle. Okay. So let's say if it's not a right triangle, consider the relationship between C and the opposite sides. So let's make an angle here that's smaller than 90. Looks like that one's 90 though, so that's not gonna work. Let me go smaller still. Okay, there we go. All right, so this angle in here is less than 90 degrees. And I got B, C, and A here. So if that angle is less than 90, then when I add up A squared and B squared, that is going to be bigger than my C squared side. So if this happens, then my triangle is going to end up being acute. If the other way happens, so now let me make an angle that's bigger. So if this happens, when I do my A squared plus my B squared, that's actually going to end up being less than. So again, if I make this angle greater over here than 90, so then when I add up A squared plus B squared, it's going to be smaller than C squared. Okay? So that leads us into two theorems. So if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, so if the C squared side is greater, then the triangle is obtuse. I didn't really draw a very good picture up here, right? Because I probably have an obtuse angle up here, so I don't like this picture now. So I'll make it almost right. But so I'm still less than 90. Okay. So anyways, back down here. So I've got A, B, C. I mean, what I wrote up there is still right, so whatever. A squared plus B squared, C squared, less than. Okay. Again, if the square of the length of the longest side is greater, so this is greater than the other two sides squared when they're added up, then the triangle is obtuse. If the square of the longest side of the triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. So if A squared plus B squared, so if the C squared side is less than those two, then it's acute. Is a triangle with side lengths 7, 8, and 9 acute, obtuse, or right? So again, that's going to be your C. So you're checking to see, so you have 7 squared plus 8 squared. How is that related to 9 squared? So 7 squared plus 8 squared is 113. 9 squared is 81. So then it's greater. So then the C squared side is less than the other two sides. So then this one is acute. Okay. All right, so we're going to do a couple homework problems together. So all right, first one I'm going to look at is 22. So 22 says, a painter leans a 15-foot ladder against a house. The base of the ladder is 5 feet from the house. To the nearest tenth of the foot, how high on the house does the ladder reach? So you just want to find this side right here. You can call it whatever. The distance here in the house are forming a right angle. So I have 5 squared plus B squared is equal to 15 squared. So then you can just do 15 squared minus your 5 squared. So I get 200 there. So b squared is equal to 200. If I wanted to simplify the radical, 200 is the same thing as 2 times 100. So when I took the square root, I'd have 10 square roots of 2. Or, so back up here, I could have just done, so it says I could round it to the nearest 10th. So I could take it there. But again, look, if I did this, I get the same answer, okay? So if I approximate it to the nearest 10th, it's 14.1 feet. Okay? So that's 22. Let's look at 32. So it says here, the lengths of the side of the triangle are given. Classify each triangle as acute, right, or obtuse. All right, so in 32, if you don't know, obviously the square root of 11 is bigger than the square root of 7, but if you don't know if the square root of 11 is bigger than the square root of, than just 4, then check. So, okay, look, 4 is the biggest side. So then I'm going to have the square root of 11 squared plus the square root of 7 squared equal to 4 squared. So this ends up being, or not equal, I'm trying to figure out what it is. What is that? So that's a question mark. All right, so the square root of 11 squared is just 11. Square root of 7 squared is just 7. 4 squared is 16. So again, I'm trying to figure out what that relationship is. So I've got 18. So 18 is bigger than 16. So if 18 is bigger, so my c squared side is smaller. So if my c squared side is smaller, then it is acute. All right, and then, okay. All right, we're going to look at 45 together. So with 45, it tells you here in 45 that you're finding integers j and k such that the two given integers in j represent the side lengths of an acute triangle, and b, the two given integers in k represent the side lengths of an obtuse triangle. So it could be that j is the long side, so then 6 squared plus 9 squared has to be greater than j, so j squared has to be less than those two added up. It could be that 9 is the long side. Obviously 6 is not the long side. So it could be that 6 squared plus j squared is greater than 9. If you do it this way, j ends up having to be less than 10.8. If I look at it from this perspective over here, so I'd have 9 squared minus 6 squared, so j squared has to be greater than 45, square root that. We get 6.7, so j has to be greater than 6.7. So basically, j could be anywhere between 7 and 10, inclusive of 7 and 10, okay? To do the acute side, so part B, so it could be that 6, so it looks kind of the same. 6 plus 9, when you add them up, would be less than the k squared side. Or it could be that 6 squared plus the k squared side is less than 9 squared. This way over here, we end up again getting that 117. Oops. So then k has to be greater than 10.8. And then over here, if you do it this way, so you get k squared is less than 45, so k is less than 6.7. So k could be less than 6 or equal to it, obviously, but on the other end it has to be greater than 0. Or k could be between so k could be 11, sorry, I should do this differently. And then what is that number up there? So then, and this actually might not even be 0 either, because if we think about, this one is a little bit of a pain. So 6 plus 9, so going back to our other triangle rules, remember back in chapter 5, 6 plus 9 would have to be greater than k. 6 plus k would have to be greater than 9, and then 9 plus k would have to be greater than 6. This one's going to give us a negative answer, so I don't care about that one. This one right here, so 15, so k has to be less than 15. So it has to be less than 15, so it's if I'm looking for an integer, it's less than or equal to 14. Here, k greater than 3, so it's not 3 here, it's going to have to be 4. Okay, so k can be between 4 and 6. And again, that's coming from this, assuming that 9 is the long side, or k can be between 11 and 14, again that way, assuming that k is the long side. Okay, that was number 45. Kind of a weird one, but there you go.